So hello everyone, and today we'll have our first session on projects discussion. We'll have many such sessions, so that would help you all to progress with your projects. And what we are basically going to do is, I hope you can see the screen that I have shared with you all. That is basically the screen of, I will reshare it. So that's the screen which basically describes all the projects. Okay, so I have anyway shared that with you all on the, it's over here. Okay, I'll open it over here. Okay, so this is the thing, and like I told you that there are a whole bunch of projects which we are proposing for students, and for most of the projects on this very page, the links and the intro etc. has been given, right? A lot of the other videos which also could be useful are present on our YouTube channel. I hope you all know what the channel is, and there are 3 different listings. There is Astronomy from Archival Data, there is AstroSprint Enterprise, and there's AstroSprint Discovery. So for whatever topic you are interested in, please have a look at the required these things. So for example, if you're going in for AGN spectra, you can see this is the tutorial file. You click on the link, this is the PDF file, which is the tutorial, right? Which is the one which describes the project especially, specifically. And then if you actually, yeah, so then what you do is you can actually go through the tutorial file, the Python file, as well as the videos, right? And so I would request all of you all to, it's very good that you've already started making your group, make your groups in, 1 second. 1 minute, yeah. So what you all have to do is actually look into the projects which you're interested in, right? For example, if it is Gaia and Python, then there are certain videos which are provided over here, which are with reference to that. If you're interested in cosmology, there's a video, article, etc. So please use this page. This is going to be your main page, which will guide you to do all this, right? And then what we are planning to do is that project-wise, we will have sessions, right? And where you can discuss your doubts and questions. Now, obviously, we are not experts at all these topics which are listed over here. So, for example, the cosmology students, if they already have reached some level, in the sense you've already watched the video, read the article which Sir has recommended, and then if you have specific questions, then I can fix up specific sessions with the people involved, right? So with Patrick Sir, we can have the session when you want to have. Similarly, whichever, if you want to have a session with Tim Hamilton, we can fix up one with him. We can fix up with whomever is this thing. So today what we plan to do is we are going to have the session on GALFIT, Galaxy Morphology, right, which will be done by Hasan Sir. And he will stop at 3 o'clock. At 3 o'clock, Sushan ma'am will take over. So Sushan ma'am students can then log in over there. Now, as usual, all these videos are being live streamed onto YouTube. And therefore, if somebody has missed any of these videos, they can always watch it later on, right? And the basic active interaction will happen on the groups, whichever groups you've made on WhatsApp or on Telegram, whichever one you prefer, right? So now we'll start off with Sir, and he's going to talk on Galaxy Morphology, GALFIT, right? And then 3 o'clock, we'll have Sushan ma'am.
So hello everyone. We have started with GALFIT in our previous sessions, and some people have had issues installing and running various things. They had problems with GALFIT itself because some libraries were missing for them, and the others in the group helped them out, and I guess the problem is resolved. Similarly, some people had problem running IRAF in their systems, installing it and running. There were cases where XZ term was not running, but I think even those are resolved. Specifically, if I open the Galaxy Morphology group, these were the 2 things. So lib and curses library was a problem. So one of the best ways of doing it is when you are running GALFIT, some people were getting an error that lib and curses is not there. And sudo apt-get install libn curses 5. If you do that and run and give your, uh, since you are running it with the sudo command, you'll have to give your password, installed. In fact, that's what I did since people were working with Ubuntu 20.04. I made a partition in my system, installed it, and ran and saw what were the issues coming with me. And then as I resolved it, I could help some people troubleshoot their problems. So, in fact, Rama Vikrama also helped people and they could do it. Okay. If there are any issues or problems, still, if you are unable to run GALFIT, or if you don't understand what is happening, basically, we can pause for a minute and discuss that. If not, we will go ahead and do other things. Then there was also a request from Sukhwinder Kaur, where she said she wanted to know whether we can do this subtraction of images in AstroPy. Okay. And also how to use the source extractor. So tomorrow we will, when we are meeting at 10, we will look at the source extractor. But as of now, we will troubleshoot problems with running of GALFIT. And once it is running, we would have made a model image. We would have made you have a sample image, you make a model out of it, and then you subtract and find the residue. And that, as we know, can be done in IRAP, or as mentioned earlier, it can be done in AstroPy. So I will just stop for a moment and check if there's something in chat. There's nothing. Okay, there is something here in chat. I couldn't find any information regarding Bayesian statistics. Okay. Priya ma'am will attend to that. And greetings and okay. So is everybody able to run AstroPy? I mean, both AstroPy and GALFIT. If there's a problem, please let me know. You can unmute yourself and speak. You just unmute and speak. Okay, so if there's nothing, Priya, can you give me screen sharing? I will share my screen and I think Richa's and Sharon's issues have been resolved.
Yes, sir. I was able to run the GALFIT file.
Okay. And even Richa had some problem. No? Who was that speaking, Richa?
Richa, sir, Richa.
Yeah. Okay. So your everything is working fine? Even Sharon's.
Yes, sir.
Yeah, I think Sharon's issues also got resolved in the morning.
Yes, sir. Yes.
Yeah. Yeah. So, and where is Sukhwinder? She wanted to know how to see one way of doing image subtraction is if you have realized in GALFIT, what we essentially are doing is we are having an image and we fit a model image to it using GALFIT. And then we do a subtraction to look at the receipt. That is the basic thing. And as we proceed ahead, we will see how to fit a double component, when do you fit 2 components, 3 components, and so on, and how to read out various values and so on. Okay. So now that IRAF is running for some of you, have you tried subtracting the images and things worked, or you are having problems with it? Okay. So, yeah. Okay, so see, you know how to start a Jupyter session, right? If you can see my screen, in Windows, you have to click the Windows button sitting right below. I can start it all over again, and I can share the whole screen and show how it goes. You click the start button and say Jupyter. As you start typing JUP, suddenly the Jupyter thing pops up, and you can here you can see this. Oh, no, you are unable to see. You are seeing some others. Anyway, so we start the Jupyter notebook. Okay, and it will open in the home location. Yeah, you can go to, yeah, so this is where can you see that? No. Just a minute. Yeah, so this is where it is. This is where it opens, and we go to the, either you start a new terminal, you start a new notebook, Python 3, and you start typing things, right? Instead, I've already done it, so I will go to the so these are the commands. You write import matplotlib plot as plt, right? Matplotlib, and if you put this %matplotlib inline, then the graphs and images which we make, they come within inline. Otherwise, they'll pop up into another screen. Okay. Then these, I'll remove these. I've made changes to this. Yeah. So now you say, I have a image called 1.img.fits, and I use this fits.getData. Okay. And when I do that, it is reading this file. Okay, let me remove these two as of now. The important thing is you are reading an image file which is sitting exactly in the location where I have invoked my this Python notebook from. Otherwise, you can give the whole path to where the fits file is sitting. So we are importing from AstroPy, import AstroPy, and then from AstroPy input output, we import this fits. Okay, these are important commands. Import AstroPy, from AstroPy input IO, import fits. And in fits, there is fits.getData, a function. And in these inverted commas, if you give the name of the file which you want to read, and if that file is located from where you are running this Python notebook, then it won't have a problem. Otherwise, I'll have to give the path to the location. And I'm storing that in the name called image1. Okay, so this is my image1. And when I say plot show image1, and these are different color maps. Okay, we'll just change that color maps and I'll show you. And you see that it is showing that image. Okay. And this just heat.r, if I change this to say gray, so then it goes into the grayscale, gray map. So there are various C maps which are there in Python. Similarly, I can use say pink and so on, and there are ways of changing the contrast. So here, see, these are the different scales, and I'm getting the color map bar also, which shows the intensity. 0 is dark, and this yellowish is 80 and 60, and on the scale, what it is. Okay, so color map. So you can specify what it is. And when we run print various things, we can get the minimum, you can get the maximum of all these things, mean, standard deviation. Okay, so print standard deviation. So of image1, what went wrong? Okay, so now coming to the important part. As you remember, in the last class, we had a gal.fits fits file, and I'm changing it into, I'm reading this data. And if you remember, we had created an image block.fits through GALFIT. And I also I'm creating a residue, which will be subtracting one from the other. So if I read this fits.getData GALFIT fits, and right, so this was the GALFIT file. And when we ran GALFIT and got the M block, this is what the M block did. And then I can, so now we have two fits file. If I call this subtract, right, is equal to, or I'll call it sub image. Yeah, any name you can give. And I have gal.fits minus, again, if I say the gal.fits, I'm subtracting the whole image from itself, fits. Okay, and I am storing it into a file called sub image. What is the name? Oh, sorry. Image. Sorry. Subtract image.gal. That was I had read that image file and I had called it image.gal. Right. So I am subtracting image.gal from itself. I mean, what I'm trying to show is you should get a totally a blank image because we are subtracting the whole image from itself. Okay. And so it has created that. And now when I try to plot this image, I will try to plot this image. Show image, and I'm calling this subtract. The name is the sub underscore image. Okay. So what you notice here is you are getting a totally an empty file because I've subtracted this from itself. Okay. So similarly, I can read this data. Similarly, I have another file called so basically this is it. And if I have plotted the when I'm residue I found, and when I am subtracting the gal image from the residue which I got from this thing, I'll have to read this thing, okay, and subtract it. So the basic idea is this. Most important things you have to do is import matplotlib plt as plt and this, import astropy, and from astropy IO import fits. Okay. Then another thing is you read the files through this. Image 1, and I will insert another one. Okay. Got it. So subtracting is, but when you are subtracting two images, they should be of the same size. And in GALFIT, if you have taken an image, you just see I subtracted this one where we've got rid of the central one. Okay. These are the files, and here they are. Okay. The same things could be done in IRAP. And I think we have seen that in the previous one. Right. Is it clear?
Yes, sir.
Yeah. So basically you have to know how to read these images into image, give some name. I'll make it so let's do it this way. This part also I will. Okay. Yeah. So point number 1, you can specify whatever name. I call this image 1. And image 1 is I'm reading fits.getData into this. Okay. Then I'll add another here where I'll have image 2, which is equal to this fits.getData, and in inverted commas, I give whatever the name is, say image block dot fits, right? Okay, so I'm calling it image 2, and then I'm adding, instead of adding, I've got rid of it. So this was image 2 is equals to fits dot get data, and img block dot fits. Okay, and I'll add one more here. I'll call this image 3, which is fits dot get data, and suppose I have a residue dot fits. Yeah, provided it should be sitting there, the residue image. If it is not there, then it would have grumbled. Okay. Now, if I want to see these images, yeah, image 1, then I'll have image. Okay, so let us see the image 1, and this is what our image 1 is, the first one which we have read, GALFIT, right? Then similarly, if I use the command and I see image 2, this is the im block which it has created, okay, which is apparently an empty file. And the third one is image 3, which is the residue which it has created. And see, this is the residue which GALFIT had created. Okay. And now if I call this is the residue. Okay. And I'll add a thing, and here I will create, I'll subtract I'm calling it subtract of what? Gal and residue, right? And I'm calling it by this name, right? Gal dot residue, and where did it go? Yeah. And this is basically image 1 minus image 3. Okay. And now I can plot and see. I will plot and see this subtracted one, which is sub name is gal res. Okay. And this is the subtracted one. So when I am subtracting this one residue from the first one, which is the image, what I'm getting is only the central one. Okay. So this is the way you subtract images. Okay. Yeah. And all these are. And here's another thing. This is same image data equal to fits get data, same one. But if you are getting it from some location on the internet, then you give the address, HTTP, this, wherever the fits file is. And this is what will give us this will, if I say image underscore data, which is the name of that file where we have saved this image, and we see this is the right. So either you can get the fits file from a specific location on your hard disk or from internet or whichever, but the basic way you can read data into the file is you have to use this AstroPy, and from AstroPy you have this IO input output, import fits from that. This allows you to do all things which you require to do with the fits files. And you are using fits.getData and reading it into a certain name, whatever name is specified. So I've read out 3 in this case, and then you can do addition, subtraction, whatever. Because these fits, basically these CCD frames, you can treat them as a matrix. They are picture elements. Each pixel has a count, and they are basically numbers. And when you are subtracting one from the other, then you are just doing matrix subtraction, right? You can add frames, subtract frames, you can do flat fielding and other things. We'll come to that as we proceed ahead. Okay. So let me stop with this. If you want, I can share these. These are this Jupyter notebook. You just have to adapt it to files which you have. And if you notice, we are, yeah, so these files are, I have dumped it exactly this img dot fits here, GALFIT, block, image block dot fits, residue. All these are sitting right here. That's why I could do these things right away. Otherwise, I would have had to specify the location where this thing is. So where my fits image dot this thing is sitting, same location I have all these files sitting there. That's why I could just put those two. I could just write the name of the file because it was sitting locally exactly at that point. Otherwise, I have to specify the path to that location. Okay. So this is what some people wanted. And the same things I think you can, for those where IRAF is working, you can do the same things through IRAF. Do you like me to show that or?
Yes, sir. You can show it.
Yeah, so maybe I'll have to, this I was showing through the machine. I'll have to from the see because yeah, before we proceed, I'll just would like to show you one specific thing which people had been asking earlier, whether you can run Linux within Windows. Okay. And yes, you can do that, but as discussed earlier, there are issues. I'll just share the screen and I'll show you. Yeah. So if you notice here, this is my Windows, and I have one for Bash, Git, right? So Git login terminal, and this is exactly like the term which we have in Linux and or in Mac and how we use. Okay. Similarly, I have one here, Sigwin. Sigwin somewhere here. Can you see it?
Just type CY. Type CY.
Yeah. So see, this Sigwin, if I run, it gives me an environment, but here only some very basic commands of Linux can be used. For example, we have listing of files and make directory and FTPing and other things. So it gives you a terminal. I can start a VI editor and I can work here, right? So simple things. But if I want to execute, I could also install GCC here, and I could create a small file. For example, I have this test.c file where I have a simple program which just prints hello. And since I installed a GCC compiler from within this terminal, I could compile it and I could get the executable file. And when I run this a.exe, then we have to say a.exe, it will run also, see, hello, right? So simple things can be done. But the question was whether you can run GALFIT from here. So though I have GALFIT downloaded and unzipped somewhere here, and I have a GALFIT here, but I cannot run it through this because the GALFIT which we have, which we are downloading, is a compiled one from the net. Yeah, if you recall, if you go to GALFIT page, it tells you whether you want a Red Hat version or Ubuntu, Debian one, or Mac Maverick, or the other ones, 6432-bit. So these are compiled programs. You have galfit.exe, a compiled binary which runs. So here, since we are in Windows, that GALFIT is not working here. I've tried it. But if we can get that GALFIT code, source code, and compile it here, and create an executable like I have done it for this C file, then it will work in this. Otherwise, it will not. Okay. So what is the other option? A bad option for that? Bad option is you can install Linux within Windows using a virtual toolbox. So if you notice here, I have a virtual toolbox, and in this, if you see, you can create a new one, and then you say Ubuntu, like I tried to create Ubuntu 20.04, And then when I started that, it asked me to specify a location where it has to be installed and an ISO file and so on. And see, for example, I have a ISO file I have given instructions to, and either I can install it here or I can say just run it. So I'm now running Linux within Windows. If you notice, I'm just running Linux within Windows. Yeah. So here basically I'm running it. I've not yet installed it. Just allocated a space in my hard disk where I say this is where I'm going to install, and it's trying to boot in. So basically your resources of your computer become overused. You are running Windows. Inside that you are running a virtual box, and in that you are going to install and run Linux. So the whole thing becomes a bit slow. But yeah, so now you can notice. See, now you can. Okay, so now it is letting me try Ubuntu or install Ubuntu. So I will just go for a safer thing where I'll say try. You can even do the installation one. But as of now, I would like to do it before I back up my system. But this is how the thing will work. Your machine will become a bit sluggish, but it can be done. It's not that it can't be done. And if you have, so now we are totally in a Linux environment, and now you can have everything going, right? I can install it, or I can start a terminal. And now if I have this GALFIT and stuff here, I can run it here. But as you notice, the whole thing is becoming slow and yeah. So I'm running Linux within Windows, and okay. So now if I've downloaded GALFIT and etc. here, then I can run this. I don't have it exactly here, but now if I have this and I run it with my readme file and other things, it will run. Okay. So this is how you can use a virtual box and run. Yeah. Okay. Right. So you can download, as you see, you can download this VM virtual box and run it through that. Okay. Now coming back to, I'll have to. Just a minute. I don't have. Can you give my share permissions to? Just a minute. I need. So I think, what you want to do is start it. The whole screen.
Advanced, go to advanced maybe. Desktop. But you have this and that desktop. What's getting shared?
Okay, so let me start again. Okay, so one way is either you can start a terminal and you can start IRAP from here. But one way of doing it is show applications, and I have IRAP installed here. So when I say IRAP, it has opened it. Similarly, from here, I will open this SAO image DS9. Where did it go? It is open now, right? So now I'm located here, and if I look at, if I do an ls, it shows me where I'm located, and I will go into this GALFIT works. Okay, CD GALFIT work, and there I have, I think, examples. CD GALFIT example. And in that I have examples. Okay. Here I have that GALFIT speech file, which was the main one, PSF file, which we had it, and I've created this residue by running GALFIT. And okay, so I'll display this gal.speech file residue dot the second file. Right, this is the residue. Here, you can see Residue 2. The whichever. Here, one of the ways of doing it is called in arithmetic. Right? So I use an EPAR, edit parameters in arith. Right? And here what I am doing is in this case we want to subtract. And operand 2 okay. So and then coming close to.
Yeah. Performance.
So if there are any problems, we can discuss them tomorrow at 10 o'clock. We will be meeting again. So you can try out things.
9 to 11.
Okay.
Yeah, it's 9 to 11.
Okay. Anyway, in the group we'll discuss whether we are meeting tomorrow or not. Because there's some issue. I need to go in the morning. So, anyway, we'll discuss in the group.
The doubt clearing.
Yeah. So So please, y'all can start off with your work, and as you have problems, doubts, and questions, we can this thing there. Okay, 1 minute. Sushan has called me. Yeah. So we'll take a 5-minute break, and we'll meet again. Sushan man will be here. Okay. So I'll stop now. We'll keep the Zoom on, and we'll meet in 5 minutes. Yeah.